Hello there, everybody. Today we're going to be working with compound inequalities. This is lesson 36A. Here are the goals for today. We want to be able to write and graph a compound inequality from words and from a situation. We want to be able to solve a compound inequality and write an inequality from a graph. So those are our goals for today. Let's get started. Let's first begin by talking about what a compound inequality is. It is an inequality formed by joining two inequalities with the words and or. So think about what a compound word is. In elementary school, when you learned about compound words, it's taking two separate words and putting them together. So like the words dog and house are two separate words, but when you put them together, they form a compound word, dog house. So that's what we're going to be doing today, taking two inequalities and putting them together. So there's two types of compound inequalities, the and the or. Let's take a look at the and first. So I have these two separate inequalities, and what I'm going to do is graph them individually, and then we're going to graph them together and see what happens. Now we know how to graph all numbers greater than 2. So we'd have an open circle on 2, and greater than, we shade everything to the right. Okay, now if we were to graph the next one, I'm going to use a different color, all numbers less than or equal to 5, the 5 would be a little bit further over here. We'd have a solid closed circle, and we shade everything less than, going this direction. Now imagine if I were to put both of these two inequalities together on one number line. What would it look like? Do you see this one's going to the right and this one's going to the left? They'd kind of crash into each other, wouldn't they? Let's try it. So we have all numbers greater than 2, graphing this way to the right, and then all numbers less than or equal to 5, going this way to the left. Do you see how here they kind of crash into each other, don't they? Yeah. That's an and inequality, where they come together. So you see how I like to think of it as Oreos and milk, they go together. So you see here these two come together, they kind of crash into each other. Now how do we write an inequality if they come together like this? Well, in order to do this, I'm going to need to put the x here. I'm going to put that right in the middle. And you see this inequality here, comparing it with the 5? Everything less than going this way or equal to, just like that. Now over here, the red part. Do you remember how we had the red part? This was all numbers greater than 2. Well, because the x is here in the middle, do you see how the big mouth is opening and eating the x? It still needs to open toward the x here. So I'm going to open it toward the x, and then I'm going to write a 2 right here. So I want you guys to see that this inequality, if I reverse it, it matches with this part right here. Okay? So I have my x in the middle. I have the left side referring to the red part, and then I have the right side here referring to the blue part of the inequality. With the x in the middle, I have to write the inequalities together as one with the and. Kind of like Oreos and milk. They go together. All right, so that's one type. That's the and. Now let's look at the other kind. This is the or. So I'm going to first start off by graphing this inequality. All numbers less than or equal to negative 2. Well, that'd be a closed circle on negative 2. And less than everything this direction to the left. Now I'm going to put this inequality on this line. All numbers greater than 1. Well, 1 would be a little bit further over here. Open circle, and greater than goes to the right. Okay, so it looks like here they're going opposite directions. Now what if I took these two inequalities and put them on the same number line? Can you imagine what would happen? Yeah, they'd be going different ways, wouldn't they? They'd be both going out, one to the left, one to the right. So let's do it. Here I have y is less than or equal to negative 2. And here I have y is greater than 1. So this is the other kind of compound inequality, where both of the arrows go opposite directions. This is an or inequality. It's either one thing or it's the other. Kind of like Oreos or pickles. You definitely won't want to have them together. You want to keep them far apart. Okay, so because we want to keep them completely apart, when I write the inequalities, I want to keep them separate. So I'm going to write the inequality right down below for the red. all numbers, oh, sorry, this is y. Here's my y. All numbers, it's kind of a backwards y. All numbers less than or equal to -2. That's the inequality for the red line. And then over here, I have all numbers greater than 1. That's the inequality for the blue line. And because they're completely separate, I want to put the word or in between them, either this one or this one separate. So these are the two types of compound inequalities. When you take two inequalities and you put them on the same number line, they're either going to come together and be an and inequality, or they're going to go apart and be an or. So they're going apart here, one way or the other. So those are the two different kinds. Now let's take a look and see if we can look at some words and write the inequalities from words. So here's our next goal, writing and graphing a compound inequality from words. All right, so go ahead and take a look at this part on your notes. All right, here's our written statement. I am thinking of a number that is greater than -8 and less than or equal to 4. So if we look at the words here, I think you guys can see that our clue word here is the word and. Okay, so and is our clue word. I'm thinking of a number that's greater than -8 and less than or equal to 4. So just thinking of that word and, we know our graph is going to come together. I'm going to write that this is an and inequality. So a number that's greater than -8. Here's my -8. It can't be equal to. It's got to be greater than. So open circle, we know that greater than goes to the right. So it's going to go to the right, greater than this way. And then we have less than or equal to 4. Well, 4 would be about here. We want less than or equal to 4. So equal to 4 would be colored in. And less than 4 would go to the left. Do you see how they kind of crash into each other here? All right, so there I have my graph. Now let's go over to the written inequality. Now this blue part here, see that part we're going to the right, and here we're going to the left. Together we're coming together here. So we're going to want our x in the middle. Now this side of the inequality would be all numbers less than or equal to 4. Because see how the arrow points to the left, we're going to the left. But this blue part of the inequality, think about if I wrote that as an inequality. It would be all numbers greater than -8. But remember, if my x is in the middle and I write this together, you see how the big mouth is opening toward the x, opening and eating the x? I have to make it open toward the x here as well. And then I put my -8. So this part, you just have to think of this as reversed. If you were to reverse it, it would look exactly like this, okay? So this would be my compound inequality for an and, all of it written together with an x in the middle. All right, let's try the next one. Here I'm thinking of a number that is at most 0 or at least 2. Now this one, our clue word is or. So we're going to have an or graph with this one. So I'm thinking of a number that is at the most 0. So it could be 0, but that would be the very most. So I'll color in 0. If that's the very most, then we want everything less than 0. And then the other half says, or at least 2. So we could have 2, color that in, but that's the very least, which means we'd want more. So we're going to go to the right. Now you see how they're going opposite directions? We have to keep those two inequalities apart because this is an or graph. It's either one or the other. So let's go over here. The inequality for the blue part would be start with your x first. All numbers, arrow points left, so less than or equal to 0. Now for the right part of the graph, again, start with your x. All numbers, we're pointing to the right, so greater than or equal to 2. So I have two separate inequalities. I have this one referring to the left side and this one referring to the right side, and I want to put the word or in the middle. It's either one or the other, okay? All right, next one. I am thinking of a number that is more than 0 and less than 10. So and is my clue word here. You can already guess what this inequality will look like on the graph. Remember, they're going to come together with an and, like Oreos and milk. So I'm thinking of a number that is more than 0. So it looks like it can't be 0, it has to be more than. So open circle, everything more than 0 goes to the right. The second part of it says less than 10. So here's 10. Now less than 10 means not 10, but everything less than it. So I shade to the left. Do you see how they crash into each other? All right, let's see if we can write this compound inequality. I'm going to do the right side here, so this part. So I'm going to start with my x in the middle. See how this shades to the left? So my arrow points less than 10. Now this part is referring to this red part of the graph. Now do you see the blue part? Now imagine if I were to write an inequality for the blue part. It would be all numbers greater than, pointing to the right, greater than 0. Do you see how the big mouth is opening and eating the x? I want it to open and eat the x here. And then I put my 0 here. So this part is referring to this part of the graph. I just had to reverse it. Okay? So here I have my compound inequality with my x in the middle. Okay? Do you notice something about both of these? Do you see these two and inequalities right here? Do you notice how the arrows point the same direction? They're both pointing to the left. So here we both point to the left. Same thing here. They're both pointing to the left. Now when you're sitting in my classroom, you see that they're both pointing right outside to the windows. That's the case always with a compound inequality. That's an and. They're always going to both point to the left. All right, let's try the next one. I'm thinking of a number that is fewer than -6 or no less than 3. So here we have an or. So think about what that's going to look like. So a number that's fewer than -6. Here's -6. We want fewer than that. So not -6, but less than that, fewer. And then the other part, no less than 3. So could it be 3? Yep, it could be 3, but no less than that. So that would mean it would have to be more. So I'm going to go to the right. So you see how these two are separate? I want to write the inequalities separate. So for the blue one, start with the x. All numbers less than, arrow points to the left, which is the same way I shaded, -6. And then for the right part, start with the x. All numbers to the right greater than or equal to 3. Now because these two are completely separate, I want to put the or in the middle, in between them. Okay, next one. I am thinking of a number that is less than 6 and greater than 2. Okay, so this is an and. So we want a number that's less than 6 and greater than 2. So I need the numbers 2 and 6 on my number line. So we want less than 6. So it seems like not 6, but everything less than it would go to the left. And then greater than 2. Not 2, but everything greater than it goes to the right. So here they crash into each other, and they should because this is an and. So let's see if we can write the compound inequality. Okay, I put my x in the middle. Here I have left less than 6. And over here, for the 2, I have everything that's greater than 2. So do you see here how I have my x in the middle? I have my 2 and my 6. Notice that the arrows are both pointing to the left, kind of out the classroom window. Okay, last one. I'm thinking of a number that is less than or equal to -7 or greater than 12. Okay, so less than or equal to -7. Equal to -7, colored in. Less than goes to the left. Now it says or greater than 12. So here's 12. Could it be 12? Nope. Not 12. Leave it open. Just greater than 12. So to the right. Now we have two separate inequalities. Oop, my bad. I should have probably made this a red one. Keep it consistent here. There. Sorry. Okay, this inequality, start with the x. All numbers less than or equal to -7, because arrow points to the left, just like this. And then the red one, start with the x. All numbers greater than 12. And of course, we're going to have the word or in between them. Okay? Now, if you take a look at the ones that we wrote together that were and inequalities, see how the arrows are both pointing to the left. Here, same thing. Arrows both point to the left. And here, arrows both point to the left. Okay? So there we have our first goal of writing a compound inequality from words. Okay, our second goal is going to be writing a compound inequality from a situation. We're kind of taking care of the hard stuff first. So here's our situation. Imagine you're helping plan the spring dance. It's going to take at the very least 100 people to make the dance profitable. That means to make money, you have to have at least 100 people attend. But there's building safety codes. that's going to prohibit more than 300 people from attending. So the building can only occupy 300 people, no more than that. Okay, so let's take the numbers 100 and 300 and put them on our number line. 100 would go here, 300 would go here. Now, what I want you to do is to graph the number of people that have to go to the dance in order for you to make money, but not disobey, I guess you could say, the building safety code. Okay? So think about what I need: open or close circles, and where would I shade for the number of people that need to come. So here on the 100, could I have 100 people come to the dance? Yeah, I need at least 100 people to come. It'd be really great if I had more. I can't have any less than that or I won't make any money. So more than 100. Okay. What about 300? Could I have 300 in the building? Yep, exactly equal to 300. But because of the building safety code, I can't have any more than that. It's prohibiting me from having more than that. So that means I have to have less than. So I need anywhere between 100 and 300 people to come to this dance in order to make money, but also to follow the building safety code. So I have an and inequality. So we're going to need to write this inequality together as one because it comes together. So remember here, I want the x in the middle. I'm going to bring the 300 straight up, bring the 100 straight up, and now I need the inequality symbols. Now remember, the inequality symbols, they both point the same direction, to the left. Now notice this part. If I cover this up, if I were to graph just this part of the number line, do you see how it goes to the left? So my arrow would go to the left, less than or equal to. Now that's this part of the graph. Now over here, this part, right here, now you might be thinking it points this direction to the right. However, the x is not on the correct spot, right? So I would have to have my inequality symbol pointing this direction, the same all to the left. Now let me show you why. This right here is the compound inequality. But let me show you why this makes sense right here. Okay? If I take a look at this part of the graph, if I wrote an inequality, I'd have all numbers that are greater than or equal to 100. Now imagine taking this and reversing it. Do you see how here the big mouth is opening toward the x? It's opening at the x. Do you see up here the big mouth here is also opening toward the x? These two inequalities are saying the same thing. It's just that I took this and had to reverse it to get it into the compound inequality. So in that case, both arrows are pointing the same direction to the left. All right, next one. Here's another one. My run tomorrow will depend on the weather. If it is sunny, I want to run at least 6 miles. But if it rains, I will run no more than 3. So let's go ahead and graph that situation before we write the inequality. So I've got a 3 and I've got a 6. Those are the two numbers. That's what I put on my number line. So over here on the right side, this is going to be if the weather's sunny. And over here, this is going to be if it's rainy. So it says if it's sunny, I want to run at least 6 miles. At the very least 6. So I'm willing to run 6 for sure, but that's the very least. I might want to go more than that if it's sunny. But if it rains, I want to run no more than 3. So I'm willing to run 3, but no more than that. So that means I would run less than. Okay, so here's my graph. Now from this graph, I'm going to write my inequalities. Now this is an or graph. It's either sunny or rainy. So I'm going to put the word or in between there. Now if it's sunny, start with your inequality with the x, and the arrow points to the right. All numbers greater than or equal to 6. So there's my sunny. Now over here, here's my rainy. Start with an x, and here we have to the left, less than or equal to 3. And there's my rainy. So I have my two inequalities, both starting with an x, and we have the word or in between them. Okay, so there's my 2. Now I know this isn't in your notes, but I wanted to see if you were able to do it. It's a multiple choice. So it says here, in order to be admitted for a certain ride at an amusement park, a child must be greater than or equal to 36 inches tall and less than 48 inches tall. Which graph represents these conditions? Well, you see here are our choices. Okay, so next thing we're going to jump to is writing a compound inequality from a graph. So here I have my first compound inequality, and I want to see if I can write this from a graph. So you see how it comes together? It's an and inequality. Remember, with an and inequality, I want my inequality to be written together with a x in the middle. So it looks like one of my circles is on the number 6. I can bring that down. My other one's on the number 1. Now I have a closed circle for both of them. So we're going to have or equal to. Remember, this side has to do with this part of the inequality. See how it's shaded to the left, right? So my inequality symbol will be less than or equal to. Okay. Now this one over here is also closed, but remember, because this is reversed, I have the inequality symbol facing the same direction. They're both pointing to the left. Okay, pretty simple on that one. There we have our compound inequality. Let's do the next one. You see the next one is also an inequality that comes together. So see if you can do it. Put your x in the middle, bring down your 6 and your 1. Now do you see here, these are open circles. So what's going to be different about our inequalities? Yeah, you're right. They're not going to have an or equal to. Both of them facing the same direction, pointing to the left. Okay, last one. This is an or. So we're going to need to put the word or in between our inequalities. So let's write a separate inequality for each. This one right here, starting with an x. See the graph goes to the right, so all numbers greater than 6. There's our one inequality. Or we could have this side. Again, starting with an x, all numbers, in this case, it goes left, less than 1. And there's our other inequality, leaving them completely separate. Okay? Again, notice that with the ands, the x is in the middle and the arrows are both pointing the same direction. Okay, last part here is solving a compound inequality. We're going to start with just some very basic ones, and then the next day we will work with some more multi-step. So if you look at this first example here, you're going to see that there's no word or, which means this is going to be an and inequality, which our goal is to get the x in the middle. So in order to solve this, we're not just going to be putting one line down the inequality symbol. We're going to put 2 lines because there's 2 inequality symbols. And again, remember, the goal is to get the x in the middle by itself. Do you see that there's a plus 2? We're going to have to do the opposite and subtract 2. So I'll subtract 2. But not only am I going to do it here, I'm going to do it on this side of the line and this side of the line. Everywhere, on all sides. So bring down the x, bring down the inequality symbols. 5 minus 2 is 3, and negative 2 minus 2 is negative 4. Now it looks correct. There's an x in the middle, and both inequality symbols are pointing to the left, like they should be. So let's go down and graph it. I'm going to put the 3 here, negative 4 here. Looks like we're going to need a closed circle because of the or equal to on the 3, and an open circle on the negative 4. And then we'll just shade everything in between. And there we go, just like that. Now let's go over here to the or. Now we know with the or that they should be going opposite directions. So let's see if that happens. So I'm going to solve these completely separately. One line right down the middle, and the goal is to get the n by itself. Yep, add 1. Negative 3 plus 1. Now divide by 2. Negative 2 divided by 2. Okay, so there I have one set of solutions. Use a different color for the other set. Okay, now let's get this n by itself. Minus the 2. Bring down the negative 3n. Negative 4 minus 2 more. Negative 6. Okay, now I'm ready here to divide by negative 3. Now when I divide both sides of an inequality by a negative number, what happens to the inequality symbol? You're right, it flips. So I'm going to flip that inequality symbol. Negative 6 divided by 3 is positive 2. Okay. All right, so I'm going to put a big or in between. All right, so let's graph this part. All numbers less than negative 1. So here's negative 1, open circle. Less than goes to the left like the arrow points. And then over here, the red part, I have all numbers greater than or equal to 2. So close circle because of the or equal to on 2. And arrow points to the right, going to the right. Okay. Now imagine if I didn't flip the inequality symbol. It would be pointing this way, and I would have my shading go this way, and that's not what's supposed to happen with a compound inequality. So that flipping out was essential for us to do. All right, so here we have our solving. And the last thing is going to be the summary. In the summary, you're going to fill in these words here. Arrows always point you probably could have guessed it, same direction. So I'd like you to please fill out same direction. What direction is that? They're always going to point to the left. And so to give an example of that, you might want to write this compound inequality. So if I have a compound inequality, I have my x or my variable in the middle. My inequality symbol points to the left here and also to the left here. I'm just totally making this up, but just showing here that the inequality symbols are always pointing the same direction to the left. Okay? All right, that was lesson 3.6a, and you guys have a great day. I'll see you later.